Hello Math 1093, this is Dr. P with a tale of two problems. So in this video we're going to talk about how to calculate the value of a composition of an inverse trig function like the arcsine or the arctangent with a regular trig function like cosine or cosecant. Purpose of this video is to talk about how we can do these things first by thinking about special angles, and then deal with an example where thinking about special angles is not useful because there is no special angle whose tangent is -4/7, but more on that in just a bit. Alright, so let's start by talking about this first problem here. Number 1 asks us to calculate the cosine of the arcsine of, make that -√3/2. Okay, so let's do a little bit of unpacking here. What does this mean? So remember, the arcsine function, if we think of this as a machine, it takes some y coordinate and it outputs an angle measure. I don't know why I keep drawing the conveyor belt. I guess it's a source of comfort for me. Okay, so inverse sine function, or arcsine, takes a y coordinate and it spits out an angle measure. And I'm going to focus in particular on this part because this is a really useful way of thinking about what this function does and how to think about it. So remember, anytime I take the arcsine of something, the thing I'm taking the arcsine of is a y coordinate, that's the input, and then the output is going to be some angle measure. Okay, so we want to keep those things straight. Alright, in this case, it's going to be an angle measure between -π/2 and π/2 inclusive, because that's defined to be the range of the arcsine function. Okay, so this is asking the question, sine inverse of -√3/2 is asking what angle, or what angle measure, in this interval, -π/2 to π/2, what angle measure in that interval has a sine equal to -√3/2? Question mark. Alright, and if I were to draw my unit circle, I could remind myself which angle measure that would be. There we go. So I think that's going to be the angle measure that goes down here. Some would call it -60 degrees, but we're going to work in radians this entire time. This, by the way, is the 0.12 -√3/2. And that angle measure there, that is -π/3, or -1/3 of pi. So the inverse sine of -√3/2 is -1/3 of pi, or -π/3. Okay, so now, if we want the cosine of the inverse sine of that, we just take the cosine of the angle we found just now. So that's going to be the cosine of -π/3, and conveniently, I already have it in this picture. I've already drawn the angle and written down both of the coordinates. The x-coordinate of that point is 1/2. So that means that the value of this expression here is just 1/2. And we were able to do that by unpacking this expression and finding this value first. Now what we're going to find is that it's not always going to be possible to do that. We're not always going to be able to write down exactly what this angle here is, what this angle measure is. So we're going to have some other strategy. And that's where example number 2 comes in. Alright, so let's work on number 2 now. Number 2 asks us, what is the cosecant of the arctangent, or inverse tangent, of -4/7? I just picked sort of a random number there to illustrate the idea. Alright, but we can still break down this question in the same way. We can still break down this question in thinking about, okay, what is inverse tangent of -4/7? And we should always ask ourselves that. We should always ask, what does this mean? What does this mean? Even if we don't anticipate being able to answer the question exactly. And we're not going to be able to do that here. We're not going to be able to find the exact angle measure whose tangent is -4/7. But we should recognize that that is what this question is asking. So this question is asking, so this means the angle measure and the interval from, actually it's not a closed interval this time, it's an open interval, and -π/2 to π/2, whose tangent is -4/7. By the way, the reason this is an open interval this time is Angle measures of exactly negative pi over 2 and positive pi over 2 do not have tangents. The tangent function is undefined there. Okay, so what I'm going to do here, just as sort of a language tool, is I'm going to call this angle measure theta. So we're going to call that theta. So what we're looking for here is just the cosecant of theta, where theta is the inverse tangent of negative 4/7. And now I'm going to draw a picture in order to try and get some idea of what that theta looks like. All right, first thing to think about is what quadrant is theta going to be in if theta is the inverse tangent of negative 4/7? Well, this needs to be an angle whose tangent is a negative value, and it's got to be either in the first quadrant or the fourth quadrant, because those are the only two quadrants that can be the value of the inverse tangent function. If that angle's in the first quadrant, both the sine and cosine are going to be positive. There's going to be no way of getting a negative value for the tangent, so we got to be down here somewhere. And if I think a little bit further about this, I think, okay, negative 4/7, what does that represent? I can rewrite that as negative 4 over 7 and think of that as y over x, because the tangent function in terms of coordinates is defined to be y over x. So I could let y equal negative 4 and x equals 7 as a strategy for drawing a picture of this angle here. So that's the point. Let's see, x was 7, y was negative 4, so 7, negative 4. And this is my theta here. My theta is going to be this negative angle, or negative angle measure, I mean. Okay, so there's theta. I'm not going to bother figuring out the exact value of theta as an angle measure. It's not going to be like pi over 13 or anything nice like that. Just some angle measure. And we want to find the cosecant of that. That's what we got to do. So now I'm going to ask myself, okay, now that I've drawn this picture of theta, what is cosecant of theta? Well, cosecant of theta in terms of coordinates on any circle is always defined to be r over y. It's r over y. So I know what y is. Y was negative 4 here. That's my y. So I need to figure out what r is. Now r is always going to be positive, and it's defined to be the radius length of this circle here. And this circle goes out to the point 7, negative 4. And I know that I have the relationship x squared plus y squared is equal to r squared. That's by the Pythagorean theorem. Wait, not plus r squared, sorry. Back that up. Okay, try that again. X squared plus y squared is equal to r squared. So I know x is 7, so 7 squared plus negative 4 squared is equal to r squared. So 49 plus 16 is r squared. R squared then is equal to 65, the sum of those. And r is equal to plus or minus the square root of 65. R is the length of a radius, so it's always positive. So r is 65. Square root of 65. So that means that the cosecant of theta is r over y. R is root 65, and y is negative 4. So I can simplify that a little bit by pulling the negative sign out, but there's not much more that I can do there. That's about as far as I can go. So summarizing, I now know that the cosecant of the arctangent of 4/7, or negative 4/7, sorry, negative 4/7 is equal to negative root 65 over 4. And we should do a little common sense check here and see if that makes sense. Should the cosecant be a negative number? Well, I'm down here in the fourth quadrant, and what is the cosecant anyway? The cosecant is 1 over the sine. Well, the sign down here should be negative. We're in the fourth quadrant, y is negative. So the cosecant, the reciprocal of that, should be negative as well. So that part seems to hold up pretty well. All right, so anyway, the main moral of this video is that we can calculate things like this. Really, that was the whole point, is to calculate stuff like this. Expressions where we compose an inverse trig function with a regular trig function. Sometimes we can do that by finding the exact value of this angle, but those cases are sadly pretty rare. In most cases, we're going to need to do this kind of thinking over here, like in the second example, where we say, okay, what does this mean? Well, it means some angle measure, whose tangent is negative 4/7. Okay, call that angle something, call it theta. What is the cosecant of that? And that's going to be a pretty robust strategy for handling these.